morning students. Today I am going to present you a lecture on the topic that is data types in MySQL. So let's get started. Here are the list of data types that shall be used in MySQL. Look at these charts. These are the list of data types that shall be used in MySQL. Let me start with the first data type, which is tiny int. Its size is 1 byte. And we know that 1 byte is equal to 8 bits, and every bit is either a 0 or a 1. So if the size is 1 byte, it means it can store 8 bits or 8 numbers of zeros or ones, or a combination of both. And the data type tiny int can store both signed and unsigned integer values. So what do we mean by signed integer values? The signed integer values can comprise of positive as well as the negative numbers, but the unsigned integer values can comprise of only the positive integer values. Now, it can store both signed and unsigned integers from -128 to +127 as signed. Now, why signed? Because -128 to -1 comprises of the negative list of numbers, and again from 0 to 127 comprises of the positive list of numbers. As a result, -128 to +127 comprises of both the negative and the positive list of numbers, and that's why it's a signed representation. But from numbers starting from 0 to 255, it comprises of only the positive list of numbers. That's why it's an unsigned representation. Now come to the next data type, which is small int. Its size is 2 bytes, which is slightly larger than the data type tiny int. Now 2 byte means how many bits of information? It's 2 into 8, that is 16 bits of information. As we know that 1 byte is equal to 8 bits, so 2 bytes will be equal to 2 into 8, that is 16 bits of binary information. That is, with the help of this data type, which is small int, it can store 16 numbers of zeros or ones. It can store both signed and unsigned integers from -32768 to +32767, which is signed, and again from 0 to 65335, which is unsigned. Then come below, see the data type medium int. Its size is 3 bytes, which is slightly larger than the size of the data type small int and the tiny int. It can store both signed and unsigned integers from -8388608 to +8388607 as signed, and again from 0 to 16777 as unsigned. Then come below, see the integer data type. Its size is 4 bytes. It can store both signed and unsigned integers ranging from -21476836648 to +21476836647 as signed, and again from 0 to 4294967 as unsigned. Then there is another version of this integer data type, which is int. Now here the size will be defined by the user. Okay, now if the value of n that will be supplied by the user is 4, then this int data type can accommodate 4 bytes of data, so 4 bytes will be the size. But if the value of n that will be supplied by the user, say if it will be 2, then this int data type can accommodate 2 bytes of data, where the value of n will be 2. And both these data types, that is integer and int, can store signed and unsigned integer values ranging from this much to this much, which is signed, and again from this much to this much, which is unsigned. Then come below, see the next data type, which is big int. Its size is 8 bytes, which is clearly larger than that of tiny int, small int, medium int, and the integer. And it can store both signed and unsigned integer values ranging from this much to this much, which is signed, and again from this much to this much, which is unsigned. Now all these list of data types starting from tiny int till big int, these data types can represent only integer values. They cannot represent decimal values. So for decimal values, we have this float data type, which can represent the smaller decimal values, as well as the double and the decimal data type, which can represent the larger decimal values. So the float data type, which can represent smaller decimal values, has the size 4 bytes, and it can store both signed and unsigned floating point numbers. So floating point numbers means the decimal numbers, and it ranges from this much to this much, which is signed, and again from this much to this much, which is unsigned. Now keep in mind that the signed list of numbers represents both the positive as well as the negative numbers, whereas the unsigned list of numbers represents only the positive list of numbers. Then come to the next data type, which is decimal. Its size is 8 bytes. Clearly its size is larger than that of the float data type, which is only 4 bytes. As the double data type has the size 8 bytes, it can store both signed and unsigned floating point numbers from this much to this much as signed, and again from this much to this much as unsigned. Then come below, see the decimal data type. Both this double and the decimal data type has the size 8 bytes. The only difference between the double and the decimal data type is that in the decimal data type, the user can supply the precision and the scale for a decimal number. Say for example, if the type is decimal 5,2, then 5 will be the value of n, which is the precision, and 2 will be the value of s, which is the scale. Now let me show you with the help of an example. Now see this example. For the type decimal 5,2, if we supply a number that is 45, then here precision is 5. That means just before the decimal it can hold at the most 5 digits, and after the decimal it can hold only 2 digits, where 2 is the scale. So before the decimal, the number of digits that you are going to supply will be the precision, and after the decimal, the number of digits that you are going to supply will be the scale. Now in this case, the maximum number of digits to be supplied before the decimal is 5, which is the precision, and the maximum number of digits that will be supplied after the decimal is 2, which is the scale. Now for the number 45, since 45 comprises of only 2 digits, okay, so this is applicable, which is less than the maximum limit 5, and after the decimal represented as 45 point, we have 2 digits, okay, given by 2 zeros, and this is also acceptable because after the decimal we have the scale as 2, so at the most 2 digits we can have after the decimal. So this representation is correct. Now look at this representation, that is 671234.12. This is wrong. Why it's wrong? Because see, we have the precision as 5. Now if you count the number of digits before the decimal, 671234, it comprises of 6 digits, which crosses the limit 5. Okay, so that's why this is wrong. Even though after the decimal we have only 2 digits, 1 and 2, which clearly falls in the range that is 2, but before the decimal we have 6 digits, which crosses the limit 5, so this will be wrong. So this is how we represent the decimal data type. Now after the decimal data type, we have the char data type, the varchar data type, and the text data type. These data types can be used to represent the characters or the text. Now for the char data type, the size is m characters, where m will be supplied by the user. If the value of m is 4, then it will be a character 4 data type. If the value of m is 6, then it will be a character 6 data type. Okay, that means char 4 can accommodate at the most 4 characters, char 6 can accommodate at the most 6 characters. So whatever the value of m you supply, okay, that many characters can be supported with the help of this char data type. So it's a fixed length character data. At the most it can occupy 255 characters. Okay, so the value of m here can be at the most 255. Then come below, see the next data type, which is varchar. The varchar also takes one argument m, okay, which denotes m characters, and the value of m shall be supplied by the user. Now in addition to m characters, you add an additional 1 or 2 bytes. Okay, so that's why it's a variable length character data, and it comprises of a maximum of 65535 characters. That means if you add up m characters which will be supplied by the user with 1 or 2 bytes, at the most it can take 65535 characters. Then come below, see the next data type, which is text. As text can comprise of many characters, so its size is the length of characters which comprises the text. Then you add up an additional 2 byte. So if you add up, the combination can consist of characters that will be not more than 65535 characters. So it shall be a maximum of 65535 characters, and it's a variable length textual data. Then the next data type is bit. Now all these data types, that is bit, binary and blob, shall be used to represent data in the binary form. Now the first data type, bit, can be used to represent any data such as the letters or the numbers in the binary form. So for any value, the data, if it's represented in the binary form, shall consist of 0 to 64 bits. So that's why the description says it represents the data in the binary pattern. Then come below, see the next data type, which is binary m, where the value of m will be supplied by the user. If the value of m supplied by the user is 2, it can consist of a 2-byte binary data. If the value of m supplied by the user is 8, then it can consist of an 8-byte binary data. So for 2-byte binary data with m equal to 2, the data type becomes binary 2. And for the 8-byte binary data, where the value of m will be equal to 8 and will be supplied by the user, the data type will become binary 8. So it's a binary data, and it can hold a maximum of 65535 bytes. Then come to the next data type, which is blob. Now blob represents binary large object. Generally these two data types, that is bit and binary, can hold only smaller binary objects. They are not used to hold larger binary objects. So characters, digits, letters are the type of data that can be held with the help of these data types, which is bit and binary. But for larger objects such as the pictures, the images, the videos, the audios, we need a data type known as the binary large object, because this data type can be used to hold such larger data as pictures, images, videos and audio. So its size will be the length of the object, such as the pictures or the image or whatever. Then you add up an additional 2 bytes into it. So that is the binary large object data, and it can hold a maximum of 65535 bytes. Then come below, we have the date, the date time, the time, timestamp and the year data types. These are those data types which are used to represent the date and the time. Let's start with the date data type. Its size is 3 bytes, and it can hold the value of date from 1000 as the year, 01 as the month and 01 as the day, to 9999. This is the end limit for the year, the 12 as the end limit for the month, and 31 as the end limit for the day. Then come below, see the next data type, which is date time. Its size is 8 bytes, and it is slightly larger than the size of the data type, which is date, because along with date, this data type also specifies the time. and the date and time value ranges from 1001, then 0 hour 0 minute 0 second to 99991231 to 23 hour 59 minute 59 second. Then come over here. The next data type is time. Its size is 3 bytes. This data type is used to specify only the time, and the time value ranges from -838 hours 59 minutes 59 seconds to +838 hours 59 minutes 59 seconds. Then come below. Next you have the timestamp data type, whose size is 4 bytes and it's slightly larger than the size of the time data type, which is 3 bytes. And the timestamp denotes the date time value. That means it specifies the date as well as the time value, but it ranges from 1970 as the year, 01 as the month, and 01 as the day, 0 hours 0 minute 0 seconds to the mid-year 2037. Okay, so the end limit for the year will be 2037 for the timestamp data type. Next you have the year data type, whose size is 1 byte, and for this the year value ranges from 1901 to 2155, and each of these year is a 4-digit year, because why? 1901 comprises of 4 digits as well as 2155 comprises of 4 digits, and hence it's a 4-digit year. So with this I end my presentation.